When you start writing programs with the mouse, you'll find that you often want to find the distance between 2 points. That's exactly what dist does. Dist is short for distance, and it simply tells you the distance between 2 points. Here's how it works. Suppose you have a point somewhere on the screen, and we'll call it x1, y1. Suppose you had another point somewhere else on the screen, and it's at coordinates x2, y2, and you want to find the distance between them. Let's call that d. Well, there's a formula for this, and you may have even learned it in high school. It involves subtracting things and squaring them and taking a square root, and you can avoid all of that. All you have to do is call dist with 4 arguments, x1, y1, the first point, and x2, y2, the second point. And out pops a floating point number that is the distance between the 2 points. That's all there is to dist. In the rest of this video, I'll show you some other ways of using it, and we'll actually look at a couple of sketches that use it. I mentioned that we use dist when we're writing mouse routines, and we do all the time. Suppose you have the mouse floating around on the screen somewhere. We know we can always find the coordinates of the mouse using the variables mouse x and mouse y. Suppose I want to find the distance to some point px, py. Well, that's easy. To find the distance d, I just call dist with mouse x and mouse y and px and py, and that gives me back the distance between the 2 points. As you start writing more graphics code, you'll find yourself using circles all over the place, and often we want to know, do 2 circles overlap? So suppose that you have these 2 circles, and maybe they're both moving, and you want to test at any given moment to find out if they're overlapping. First, let's label everything. So I'll say the orange circle has radius r1 and its center is at cx1, cy1. And then the blue circle has a radius of r2 and its center is at cx2, cy2. The distance between them is given by d. Well, we know how to find d. All we have to do is use dist with the 2 circle centers. But now we ask, is there a way to use d to find out if the circles overlap? And the answer is absolutely yes. Here's one case where the circles don't overlap. In this case, the distance d is greater than the sum of the 2 radii. So d is greater than r1 plus r2 in this case. So we can test for that. And we might say, if d is greater than r1 plus r2, then do something that is in response to the fact that the circles don't overlap. Here's a case where d is smaller than r1 plus r2. That's our cue that tells us the circles indeed overlap. And then there's the case right on the boundary where d is exactly equal to r1 plus r2. And that means the 2 circles are just touching. Mathematicians sometimes say that the circles kiss. So when d is exactly equal to r1 plus r2, the circles are kissing. In the upper left, when the distance is greater than their sum, the circles are not overlapping. And in the upper right, when d is less than the sum of the 2 circles, they are overlapping. You can test for these conditions and have different things happen in your program. They change colors, they bounce off one another, one circle pops like a soap bubble, whatever you want to do. Another common thing we want to know is a given point inside a circle? It's really just a minor variation on this. Let's take a circle, and its center is at cx, cy, and it has radius r, and somewhere we have a point. And let's say it's actually tied to the mouse. We know the distance between the mouse and the center is given by d, just dist using the mouse values and the center of the circle. But now we want to know, is the mouse inside the circle? The way to find this out is very similar to what we just saw. Let's move the diagram up to the top of the screen, and I will mark in green all the points where d is less than r. Anytime the distance from the center to the mouse point is less than the radius, we are inside the circle. Anytime d is equal to r, we are right on the circle. And in the world outside the circle, d is greater than r. The distance from the mouse point to the center of the circle is greater than the radius. You use this kind of test all the time when you want to click on something or click on it and drag it. Suppose you have a bunch of objects on the screen and you want to use your mouse to grab one of them and drag it around. The first thing you need to know is, which object have I clicked on? If all of your objects are circles, it's really easy. You find the distance from the mouse to the center of each circle and compare it with that circle's radius. If the mouse is within the radius of the circle, that's the left-hand picture here, d is less than r, then yeah, you have clicked on that circle. And now you can remember that using some global variables and drag that circle around. If you're just trying to click on a circle, maybe it's a target game, then we have the very same thing. You test all of the circles and test to see if the distance to any given circle is less than that circle's radius. If so, you're in it. And the circle can pop away, or it can change color, or it can get bigger and smaller. As long as you can find out which circle you've clicked on using this test, you can make that circle respond any way you want. Let's look at a couple of examples of using dist in sketches. In this little program, I'm using a while loop to draw a row of circles horizontally across the screen, and I've got a big empty circle at the top. The center of that circle is attached to my mouse. As I move the big circle around, you can see that when I'm sitting on top of any of the smaller circles, they turn blue. All I'm doing is using dist to find the distance from the center of each of the little circles to the big one. And if that distance is less than the radius of the big circle, well, then I turn the little one blue. Just for fun, I can make these appear to move. I'm just adding a little bit of horizontal motion to each circle using frame count. And I can move the circle around and I can try to catch. Let's see if I can keep 3 of them under the circle. And I can move them around. So this just makes the demonstration a little bit more fun. So I'm just using dist to compare the center of the little circles with the center of the big circle. And if they're in the big circle, they turn blue. Let's see another use of dist. Here's our fox and hen program, which we saw before. I'll turn on the fox, I'll turn on the hen, and as I move the hen around, you can see the fox is chasing me. And if I turn off the background clearing, we get these nice trails from before. Now let's suppose that we change the fox a little bit. Let's say I'm going to use dist. On every frame, when I'm ready to draw the fox and the hen, I'll find the distance between them. And the smaller the distance, the smaller the radius of the fox. The bigger the distance, the bigger the radius of the fox. But everything else is identical. It still moves the same way. I'm just going to change the radius of the fox. So let's go ahead and do that. And now I'm going to start moving. Well, I'm moving slowly, so the fox is pretty small. And as I start moving faster, the fox gets big. And if I slow down, the fox gets small again. And by going slow and fast, I can control the size of the fox. And I can make these kind of cool, organic patterns. Well, maybe I don't want the fox to get bigger when he's going faster. Maybe I want him to go the other way around. Let's try that. So I'm going to reverse things. The slower the fox is going, the bigger he is. So right now the fox isn't moving at all, so it's huge. And as I start moving, the fox gets smaller and smaller. If I start moving really fast, the fox just turns into a row of dots. And I can also slow down. Let's take a look at the code that drives this. Here's the line of code from the original program. To draw the fox, I simply call ellipse. The center of the ellipse is at fox x, fox y, and the radii of the ellipse, they're both the same, which gives me a circle, just 2 times fox radius. The new version is just 3 lines long. In the first line, I call dist, and I find the distance between the center of the hen and the center of the fox. And I store that in a variable which I call DHF for distance from hen to fox. Again, I'm keeping everything super short for these slides. Then in the second line, I use map, and I convert that distance into a radius. I decided when the distance is 0, in other words, the fox is right on top of the hen, the fox will have a big radius. And that's some global variable called big fox r that I set to some value. When the fox is 100 units away from the hen, then it has its smallest value, which is, again, some global variable called small fox r. So when the distance between the hen and the fox is 0, the fox is right on top of the hen, we get the big radius. When the fox is further and further away, the radius gets smaller and smaller, until at 100 units away, it has the radius small fox r. And I just picked 100 because that seemed like a pretty good distance. I store the result of the map in this new variable called foxr, and now I just call ellipse The center is at fox X, fox Y, of course, and the radius is this new radius. So the whole trick is use dist to find the distance between the centers of the hen and the fox, and then use map to turn that distance into a radius. So let's play with this a little. As I move slowly, the distance between the fox and the hen is small, and so the fox is very small. But as I start going more quickly, the fox starts falling behind, the distance becomes larger, and the fox himself gets bigger. And this is so much fun to play with. You can really have a good time creating little patterns with this that just look gorgeous. And if you want to fool around with this kind of an idea, you can start playing all kinds of additional games with Dist. And you can change the colors of things. You can change the fox's motion a little bit, so maybe he runs a little faster or a little slower, depending on where he is on the screen, for example. Maybe there are areas of the screen where there's fox food. And if you get near the fox food, he loses interest in the hen and goes after the fox food, eats it up, and then chases the hen again. You can just really go crazy with this program and just have a lot of fun with it. But all we're doing here is using Dist to change the size of the fox based on the distance between the fox and the hen.